Okay, gentlemen, we're going to take a look at some basic review for factoring, right? So this is what we were going to cover in class today that we didn't get up to, but just a review about what factoring is for us. Maybe some of you have seen this before in middle school, maybe some of you haven't, but factoring for us is something that if you've seen it before, it's when we set the equation equal to 0 for the purpose of its roots. Now, I use the words roots. I use that probably almost exclusively is finding an equation's roots. What is another word for our roots? Well, that's zeros, which is another word I use probably second most often. Zeros is what we see in the calculator. That's when we go to second trace and if we hit calculate, you scroll down, it says zeros. That's finding the roots. What are the roots? The roots are the x-intercepts or the solutions. Now, I really don't say solutions that much because these are functions, so we kind of talk about more of them as roots, zeros, and x-intercepts. For x-intercepts, I'm going to write under this actually sometimes they're x-intercepts. When would they not be? Well, that has to do with if a function has real roots or not real roots, which if you know what that means, great. If you don't worry about it now. It's just not always, the root is not always an x-intercept. The root is always a 0. They're always roots. That's their solutions, but they're never always, they're not always x-intercepts. So first basic example that we can see, that you'll see on the homework, right? You have a brief homework on this. If I give you a function, I tell you to find the x-intercepts and y-intercepts. Well, how would you find the x-intercept here? Think about what we did when we had the y equals mx plus b stuff. We had done that on the previous chapter with the linear functions. When I said find the x-intercept, I said take the mx plus b and set it equal to 0. That was what we had to do when you were finding your x-intercept. And when you look at that, we're basically doing the same thing. That's our general procedure for how we find the x-intercepts. Previously, it was x-intercept. It's x-intercepts. Actually, I don't need the parentheses. It is x-intercepts because it is an x-squared function. X-squared functions are parabolas. And parabolas generally, almost always, generally will have 2 x-intercepts. Okay, I guess actually I'll put it back because there is a small chance it actually won't have 2 x-intercepts. Right, but it'll always have 2 roots. You'll always get 2 roots because it's x squared. Okay, so how do we do this? Well, if you've seen this before, this is review. If not, you're looking at, these are 2 terms. Here's one term. Here's the other term separated in this case by a minus sign. It could also be separated by a plus sign. And what are we looking for here? Well, can this be represented as something squared? The first term can that be represented as something squared? Yeah, that's just going to be x squared. Can the 81 be represented as something squared? Yeah, that could be 9 squared. Do I have a minus sign? Yes, that's important. We need it to be a minus sign. If not, it actually doesn't work. That is true. So now I have 0 is equal to, well, the x, because x times x will give me x squared. I'm going to have the 9, because 9 times 9 is going to give me 81. How do I cancel out my middle term, which x squared? There's just an x to the 0 here, and then where's my x? Well, I make 1 plus, 1 minus. 1 plus, 1 minus. Doesn't matter which one's which, 1 plus, 1 minus. Okay, so these are the factors of this. Just like the factors of 6 are 3 and 2. 2 numbers that multiply to give me 6. Here are 2 numbers that multiply to give me this. These are 2 binomials that multiply to give me this. Binomial multiplies to give me this. X squared, negative 9, positive 9, cancels, negative 81. Okay, now we have to find the roots. We set each one equal to 0. I'm showing all my work here as we get more involved in this, there's some of this you don't have to show. We're going to get pretty good at it, right? And just a reminder, what is this? These are my x-intercepts. -9, I have found -9 comma 0 is an x-intercept, and 9 comma 0 is an x-intercept. This is an even function, so you see that a negative number, right, even, x squared, this is really an x to the 0. -9 plugged in gives me 0. Positive 9 plugs in gives me 0. Okay, it's an even function, and when we're finding my x-intercepts, it's because we want to know when my y is equal to 0. What is the x that will give me a y of 0? What is the x that will give me a y of 0? Well, there's two of them, and these are them. These are my roots and zeros. And in this case, these are my x-intercepts, right? I will refer to them as roots most often, but these are my roots and zeros and x-intercepts because they're real. Okay, so on the homework it says to sketch. What does that mean for us? Well, my graph looks something like this. It's not a regular parabola that goes like this, right? It's slid down a little bit. How do I know that? Well, if I were to find the y-intercept, you would plug into your function 0, right? That's how we did it with the mx plus b stuff. Mx plus b, the line stuff. I plug in 0, and that would give me 0 f of 0 is equal to -81. 0, -81. There's my y-intercept. So here's my y-intercept. I found my x-intercepts, or my roots. Okay, and this is the same procedure we had before in linear equations. Set it equal to 0 and solve x-intercepts. I just got 2 here because it's x squared, not x. Plug in 0, here's my y-intercept, which happens to be the last number, as expected. I can pretty easily draw this. This is not drawn to scale. On your homework, I said sketch, so same idea. I wouldn't draw it to scale. On the answer key, I drew this picture and then copied it without the points labeled. Copied it 5 times and then just added them in, right? You don't have to draw it to scale. This is the general procedure you follow to find your x-intercepts and y-intercepts for a very, very basic squaring function, a parabola.